Hey everyone, welcome back to Crash Course. I'm Nishant, and today I'm going to show you guys how to render out your CAD models in Blender. Now, in the last video, what we covered was how to actually translate your CAD models into a 3D model that you can use in Blender, such as an FBX, OBJ, or STL. Here I have an example of a robot that I've converted to an FBX using Fusion 360 and exported into Blender. After which I applied the materials and then I sectioned it out into its different mechanisms so that I can render each separately. Now, you may be wondering what the purpose of rendering out your CAD model even is. Why should you do it? Well, the main reason to render out your CAD model is specifically for publicizing your robot, or for example, if you are in FDC, for adding it to your engineering notebook or engineering portfolio, as they display both your CAD and they add an aesthetically pleasing design that you can add to any of your pages. But back to this. How do we get from whatever this is to a render like you will see on the screen right now? Well, first we have to establish some prerequisites. So in this video, I'm not going to teach you Blender. You have to have at least some knowledge of Blender, know how to use materials, know how to use lights, and create just general objects, such as the scenes you might make with something like a plane, as you can see here. So, if you don't know Blender, and you're just now figuring out that you can render out your CAD models with Blender, I recommend checking out Blender Guru's donut tutorial. It's what I use so that I could get good at Blender, so that I could render out these sort of objects. Once you do that, come back to this video, and you should be able to understand most of what I'm saying. But now, moving on to the main topic of actually, well, rendering out your design in Blender. So, once you've gotten your CAD model into Blender, your first, essential step you should take is always to consolidate your pieces into one movable piece. This can be in the form of a cube you label around, you create around the object. It can be an empty, you create an object. Just anything that allows you to move all the parts simply by moving one through parenting. In this case, I have created an empty using Shift-A, empty cube, and scaled it along its axes so that it fits more or less with the actual robot. In your case, it could be any sort of mechanism. It could be a very tall tower, it could be a ring shooting mechanism. As long as it's a mechanism or an object, you want to add something that will be able to control it and move it just by moving one part. So for example, if I wanted to move this robot anywhere in the Blender framework, I can just simply click G on the empty and I'll be able to drag it anywhere. The next step, once you've set up your empty to move everything along, is to section out your model. So in the case that you only just want to render out a single mechanism or whatever piece you've created, and you don't need to section it out, the whole mechanism is in and of itself complete, then you don't need to do this, and you can simply move on to adding materials and adding lights and actually creating your render. But in the case like here, where you do have multiple mechanisms you might want to render out separately, for example, if you wanted to talk about your ring shooter mechanism or your intake separately in, for example, your engineering portfolio or your engineering notebook, you might want to have separate renders for that, which necessitates actually separating out the different parts in your model. So the way to do that, and the most effective way I found in Blender, is simply to select different parts and place them into different collections. That is what I have done for this robot, and so for example in the intake I've selected every single part in here that corresponds to the intake. So if I didn't want to see this in a render I was doing, I only wanted to see all the mechanisms in the back, then I could simply unselect the intake and it would no longer show up in the render. Additionally, to check, you can simply turn on disable in render, which is this camera icon. As you can see, it has been disabled in both viewport and render, so it will not show up. But let's bring that back. Just to be clear, the actual way to move an object to a collection is simply to right-click on it, then left-click so that you can open up the object context menu, or simply click M and then move it to the collection of your choice. You can do this with multiple objects selected, as you can see. And that is how you move them to collections. Another thing to note is, especially when you have parts that are meant to rotate or translate, for example, in the case of this arm, you can parent them around the axle or shaft they would rotate or move along in real life. So for example, I've parented the majority of this arm to the axle it would rotate around in real life. So now, simply with the R tool, or the R key, and a selected axis, I can rotate this along the x-axis and, in a way, pose the actual model such that it would fit within whatever renders I set, or act how I want it to. You can do the same thing for these flip-out arms, or any really mechanism that rotates around an axis or slides along an axis. Additionally, you can also do this for things like the wheels, so that you can create keyframe animations for things like publicizing your team or your robot in general. Now, let's move on to the hardest step of rendering out your CAD model, and that is creating the materials for your model. This is usually the hardest step, depending on how complex your mechanism is. If it's got a lot of unique parts and it's very large, this can take up to 3 hours. If it's not that large and it's got a lot of repeated parts, this can take 5 minutes. It really depends on how much effort you want to put in to make your materials look as good as possible. In the case of FTC, you really don't have to put in that much effort. Most of the time, just a principled BSDF shader with some changes to the color and the actual sliders will give you a relatively workable material. For example, in this case, we have a metal side plate that we painted in real life, and in Blender I simply represented it with a metallic matte material. Similarly, I copied and pasted the same metal material for all metal pieces on the robot. No one is going to scrutinize your render that closely, so you can usually get away with stuff like this. Additionally, keeping your materials as simple as possible helps with render time, which is probably going to be your biggest time waster in Blender in general. Additionally, if you exported your design from Fusion, you get the added benefit of your materials propagating. So for example, if you've reused a part multiple times, such as in the case of this screw here, I've reused it for all the screws on this side plate, and so the material I assign for any one of them will propagate to all of them. So this makes your job a lot easier. Additionally, as you keep doing this, your job gets easier since you can append your material from previous iterations of your robot or just other renders you've made. So now that you've completed the actual model part of rendering out your robot, you can move on to the rendering out your robot. So in the case of FTC, there's two main ways to do it. In some cases, you might want to have a background for something like if you were rendering for social media, so that you can make a post about your robot. But in the cases, for example, where you might want to use this on something like your portfolio, it would be best to actually render it on a transparent background. Now, this can be done by simply going to Scene and going to Film, and then selecting Transparent. This will turn your render transparent, so any background in the camera view in this rectangle or square that you have that is the world background will actually end up as transparent. And that is how you create transparent renders that you can use in a wide variety of things, from thumbnails, if you were making YouTube videos like we are, to something like your actual portfolio, which you can place text around and annotate. An additional note about rendering for the portfolio is that when rendering out your mechanisms for the portfolio, the best perspective for your rendering is not actually perspective, but rather orthographic, as this will show the most detail on your actual mechanism than a perspective view might. So, for example, the way to change it is by simply selecting the camera that you're using to view your model, changing its type to orthographic, and then editing it such that its actual orthographic scale fits the robot or mechanism into the actual camera viewport. So here it does it pretty well, and as you can see, it shows each of the side lengths without having a perspective skew. If you want to create a fully isometric view, you can actually change the angles that the camera is placed at. For example, if you go to the transform and change the X to 45 and the Y to 120, you will end up with a fully orthographic view. Now, let's move on to lighting. So, in general, your lights in FTC don't have to be too complicated, they just have to show off your mechanisms. Again, this is just my personal preference, but I usually use an overhead area light, which I use to illuminate much of the actual model, and then I place numerous little point lights, which I use to highlight small areas of the model that I want whoever would read my portfolio or see my renders to especially notice. So now finally we can get started talking about the actual rendering. So this all depends on how good your computer is. So if you have an extremely powerful GPU, or just a regular powerful GPU, or even a really powerful CPU, you can make render times drop from 5 to 6 hours down to 10 or 12 minutes. So I recommend, especially if you are going to start rendering, to at least have a gaming computer on hand, or at least one that you can borrow to render out your image or your animation or whatever you're going to render out, and then give it back to them. If you have a low-end computer and you also just want a faster render, you can also just use the Eevee render engine and set all of the actual options for it, which will give you a relatively photorealistic render, though it will never be as close to photorealistic as Cycles is. So now I'm going to show you an example render. So I have my camera set up. As you can see, it's got the robot in view. I've got my robot on a plane. It's got lighting. So I'm going to render it out. So as you can see, I'm using branch path tracing with 300 samples. The main two things you want to focus on here is the diffuse and transmission, as those are the points where you would likely want the most, well, actual definition. For most of the others, you can usually keep them at 1 or 2 samples branched each. So now that I have everything in place, I'm just going to start rendering. I've lowered the sample count to 50 so that I can just get a fast render and show you guys what you can do after with compositing and how to actually save the images. Remember, you always want to be using your GPU rather than your CPU for rendering, but you can use your CPU if your GPU is not powerful enough or is not working with Blender. So I'm just going to hit F12 to start the render. Depending on how fast your computer was, this can take from 10 minutes to 5 hours. Again, all depends on how good your GPU is. And there we go, we have one finally completed render. As you can see, this took quite a while, even though it was a relatively low sample render. So again, your GPU really matters for this. If you do not have a powerful enough computer, it may not be worth it to actually do renders. And finally, we have the final step of compositing. So what you'll likely end up with is a page that looks like this. You can save your image separately up here, or you can simply close this page and navigate over to Blender. Then you want to navigate over to the Compositing tab, where you'll have a page that looks like this. You'll need to change this image from Viewer Node to Render Result, which will show what the result will look like. Right now, I have a denoiser set up. This denoiser allows me to use far lower sample renders and still get high quality images. If I simply remove the denoiser and only connected it directly to the alpha, it will have a lot less quality and a lot more spottiness. As you can see, there's a lot more white spots simply because the render didn't have enough samples. As soon as I use the denoiser, however, these spots should disappear. And there we go. Now, denoisers are mainly just if you're creating a render and you don't have enough time to have large sample sizes. If you want to have a render that will still look good under zooming in, then I would recommend not using a denoiser. Another thing just to keep in mind, when using a denoiser, you will have to turn on denoising data. So if you navigate over to the third scene, view layer, you will have to check denoising data. Otherwise, you will not be able to use the the denoiser in compositing. And to be clear, how you activate the denoiser is simply click Shift A. You can go to Filter, and then select Denoise, which will bring up this node. Then connect the noisy image, the noisy normals, and the noisy albedo, and then connect the denoised image to the compositor. And you should end up with a relatively clean looking image, regardless of how many samples you've taken. And that's it. That's all there is for compositing. Remember, if you need to know more about Blender, there's lots of videos on YouTube you can check out to get the knowledge needed to do this sort of stuff. But as for now, that's it for this video. Thank you guys so much for watching. Please comment if you have any questions. And yeah, I'll see you guys in the next one.